everyone, welcome to Drawing Hub. So this is Computer Graphics and Image Processing Module 1, Part 11. So in this video, we'll be discussing about Bresenham's line algorithm. In the previous video, we have discussed about the DDA line algorithm's problems. So in this video, we'll be discussing about Bresenham's line drawing algorithm. Now, an accurate and efficient raster line generating algorithm developed by Bresenham. So the name was originated from its creator. Can converts line using only incremental integer calculations that can be adapted to display circles and other curves. Now in this figure, this is a section of a display screen where a straight line segment is to be plotted. Starting from the pixel at 10 on scan line 11. So it is starting from 10. This is a specified line path. Now this figure illustrates the sections of a display screen where straight line segments are to be drawn. The vertical axis shows scan line positions and the horizontal axis identifies pixel columns. So this represents the scan line positions. Okay, that is y-axis represents the scan line positions and the x-axis identify the pixel columns. Sampling at unit x intervals in these examples. We need to decide which of the two possible pixel positions is closer to the line path at each sample step. Now starting from the left hand one, in this it starts from here, right? And we have to find the left hand point. Now we need to determine at the next sample position whether to plot the pixel at 11:11 or on at 11:12. So we are having this position. We have it over here and we have it over here. See why? Because only it can pass through one at a time, but it is passing in between, right? So we have to decide in which of these 2 points, in which of these 2 pixels the line should pass through. Okay. Similarly, in figure 3.6 shows a negative slope line path starting from the left hand point at a pixel position 50-50. In this one, do we select the pixel position as 5150 or 5149? See over here, it is a deteriorating graph, right? Now in this 5150, so should we select this point or should we select this point? Why? Because the line is passing through the middle. Now there is a confusion. Through which pixel it should pass through? So that is the question. So these questions can be answered with Bresenham's line algorithm by testing the sign of an integer parameter whose value is proportional to the difference between the separations of the 2 pixel positions from the actual line path. Now to illustrate Bresenham's approach, we consider the scan conversion process for lines with positive slopes less than 1. Okay, we take less than 1. Pixel positions along a line path, so they are determined by sampling at unit x intervals. So starting from the left hand point, that is if we have a graph like this, it starts from here. This is x0, y0. It starts from here. We step to each successive column, x position, and plot the pixel whose scan line value. That is, we increment the x's value and just like how we did in DDA line algorithm only, but here the formula will be different. Whose scan line value is closest to the line path. So now we will determine, we will take the pixel through which, see, if we look visually over here, maybe this one is closer, then we will take this pixel. But it is not like that. We will do the calculation and then after that, which one is more closer, which one is more nearer, that one we will select. Okay. Now here again we have another figure demonstrates the kth step in the process. Okay. So this is after applying the formula. So now we will go through how we do it, the formula. Assuming we have determined that, so this is our problem, the problem statement. Now we have to get the solution for that. Okay. Now asked at sampling, okay, Assuming that we have determined that the pixel xk yk is to be displayed, we want to display xk yk. We next need to decide which pixel to plot in column xk plus 1. So we need xk yk and xk plus 1, which pixel should we plot? Our choices are the pixels at position. We have xk plus 1 yk and xk plus 1 yk plus 1. See, we have xk plus 1 yk. See, that is either this position or this position, that we are writing it in a variable format. Xk plus 1 yk, or it can be xk plus 1 yk plus 1. See, it can be this one or this one. This is see, this is xk. If you are taking xk, this is xk. Then this is xk plus 1. If this is yk, then this is yk plus 1. So we want to find xk plus 1 yk. So it can be this one, or xk plus 1 yk plus 1, or it can be this one. So we have to choose which one. We have two choices. So at sampling position xk plus 1, we label vertical pixel separation from the mathematical line path as d1 and d2. The y coordinate on the mathematical line at pixel position xk plus 1 is calculated. So now we have the new formula. Y is equal to mxk plus 1 plus b. The line formula. Remember the line intercept formula? Y equal to mx plus b that we have learned in the previous video. Y equal to mx plus b. Similarly, here we want to find the xk plus 1. It is not x, it is xk plus 1. Then we have d1. That is, instead of delta y and delta x where we use in DD algorithm, here we are using d1. So d1 is y minus yk. Okay. Now we are substituting the value. See, here we have got y. Now this is equation 1. Now we are substituting this value of y over here. So that will be mxk plus 1 plus b minus yk. Now d2. What is d2? Yk plus 1 minus y. Okay. Now there it will be, we are substituting, see, yk plus 1 is like that only. For y we are substituting this value. So yk plus 1 minus mxk plus 1 minus b. That is, after opening the bracket, it will be minus mxk plus 1 minus b. Now we will take the difference of this, that is d1 minus d2. So over here I have expanded it and written, that is mxk plus 1 plus b, and then after opening the bracket, negative values will be there. Then we have mxk plus 1, mxk plus 1, that is 2 mxk plus 1 minus, we have yk and minus yk. So that is minus 2 yk, and we have b and b, 2b and minus 1. Okay, we have got the equation. Now a decision parameter pk for the kth step in the line algorithm can be obtained. Now after we rearrange this equation, we will get another pk value. So that is what we call the decision parameter pk. Decision parameter pk. This is important. Now we accomplish this by substituting m is equal to delta y by delta x. Remember the formula delta y by delta x? Yes. And we get it using that formula, where delta y and delta x are the vertical and horizontal separations of the endpoint positions. And defining. And now we get pk is equal to delta x d1 minus d2. Now we get pk equal to delta x d1 minus d2, and then we substitute. So we will get 2 delta y xk minus 2 delta x yk, and we get the constant c. Now the sign of pk is the same as the sign of d1 minus d2. Since, see, sign of pk, whatever is the sign of d1 minus d2, that will be the sign of pk. Why? Because delta x is greater than 0 in this example. Now parameter c is constant and has the value 2 delta y plus delta x 2b minus 1, which is independent of pixel position and will be eliminated in the recursive calculation. See, this one we will not be taking. Okay. If the pixel at yk is closer to the line path than the pixel at yk plus 1. If yk is closer, that is d1 greater than d2. Yk closer means d1 is lesser than d2. Okay, then decision parameter. So in that case, if d1 is lesser than d2, then pk is negative. In that case, we plot the lower pixel. Okay, so in this case, we will plot the lower pixel. Otherwise, if d1 is greater than d2, we will plot the upper pixel. Now, coordinate changes along the line occurs in unit steps in either the x or y direction. Therefore, we can obtain the values of successive decision parameters using incremental integer calculation. So now, this is a section of screen grid showing a pixel in column xk on scan line yk that is to be plotted along the path of line segment with slope 0 less than m less than 1. See, this is a line with the equation y equal to mx plus b. This is xk yk. This is xk plus 1 yk plus 1. So it is over here. It can be xk plus 1. The next point is going through the middle, right? So it can be either xk plus 1 yk or xk plus 1 yk plus 1. And we have to decide which of these pixels it should go through. Then we are taking the step k plus 1. Here the decision parameter from the previous equation we are taking. That is from this equation we are taking. That is pk plus 1. See, pk we have got it as 2 delta y xk minus 2 delta x yk plus c. Then pk plus 1 will be just add plus 1 to the key. See, over here we have keys, no? Just add plus 1 to it. So we will get pk plus 1 equal to 2 delta y xk plus 1 minus 2 delta x yk plus 1 plus c. Now then we subtract pk plus 1 and pk. So pk plus 1 minus pk, we will be getting 2 delta y xk plus 1 minus xk minus 2 delta x yk plus 1 minus yk. Now here xk plus 1. In subscript it is k plus 1, that is also xk plus 1. So then we can write pk plus 1 equal to pk plus 2 delta y minus 2 delta x yk plus 1 minus yk. Now here the term yk plus 1 yk, it can be either 0 or 1. So that will be depending on the parameter, the decision parameter pk. Now this is a recursive calculation. So this recursive calculation of decision parameter is performed at each integer x position, starting at the left coordinate endpoint of the line. The first parameter p0 is evaluated from this equation. Okay, at the starting point pixel position x0 y0 and with m evaluated as delta y by delta x. Now, p0 means we apply k is equal to 0, we will apply. So we will get p0 equal to 2 delta y minus delta x. So this is our first equation, important one. Okay. So now here, so this is the distance between pixel positions and the line y coordinates at sampling position xk plus 1 yk plus 1. See this one, this is xk plus 1 yk, this is y, and this is through where the line is passing, and this is xk plus 1 yk plus 1. And look at the distance over here. D2 is lesser than D1. So we will be selecting which one? Of course, the smaller one, right? Okay. Now we can summarize Bresenham's line drawing for a line with a positive slope less than 1 in the following listed steps. So for the input, now we are coming to the formula, the basic algorithm. Now if it is mod m is lesser than 1, then input the two line endpoints and store the left endpoint in x0, y0. We have two endpoints and we store both the left endpoint in x0, y0. And now we load the x0, y0 into the frame buffer. That is a plot the first point, that is loading. Now calculate the constants. We have to calculate delta x, what is delta y, what is 2 delta y, then 2 delta y minus 2 delta x. We have to calculate all this and we have to get the decision parameter of the starting value, that is P0. P0, how will we calculate? It is 2 delta y minus delta x. Now at each xk along the line, we start from k is equal to 0. We will perform the test, that is, if pk is lesser than 0, we will use this formula, xk plus 1 yk, and we'll get pk plus 1 equal to pk plus 2 delta. Now if it is pk is greater than 0, then we will use xk plus 1 yk plus 1. So at that time pk plus 1 is equal to pk plus 2 delta y minus 2 delta x. Now this we will repeat delta, that is this step we will repeat delta x times. Okay. Now we have problems to do that we will be discussing in the next video. So then bye bye.